So in 5G new radio, efficient use of time and frequency domain is key to achieving the flexibility. Now, here we are taking one example to understand more about the different channels and signals that are present in 5G. So in a radio interface, we have the frequency and time domain grid, where we have different resources allocated for different purposes. We have logical and physical channels that are mapped onto these resource elements to serve distinct purposes. Here we are taking an example of numerology of 0 with the 15 kilohertz subcarrier spacing. We have the different allocations of channels here for different purposes. For example, we have here the PSS and SSS, which is the primary and secondary synchronization signals, which are used by user equipment for cell search, for synchronization, and identifying the physical cell ID. It is used for initial access procedure as soon as the handset switched on. These are the channels which needs to be decoded to have a communication established. We then have the physical broadcast channel, which carries the master information block. Now, the master information block provides the key parameters needed for user equipment to begin decoding the network, like what is the system bandwidth of the network, what is the system frame number, and so on and so forth. We have then the PDCCH, which is a physical downlink control channel. Now, this carries the control information such as the downlink and uplink scheduling branch, how the process would look like for the hybrid automatic repeat request, and what is the modulation and coding schemes to be used. So it has to be decoded before the actual data to be transmitted. It is essential for dynamic scheduling also. We then have the actual data, which is being carried by the PDCCH, which is physical downlink shared channel. It transmits user data and higher layer signaling. It is highly flexible, occupying dynamically scheduled resource blocks for data. After PDCCH, there are certain other different signals which can be used for reliability and performance of the data transmission. There are two reference signals which are used here. One is the demodulation reference signals. Its purpose is to help UE demodulate the PDCCH by estimating the radio channel. We also have the CSI-RS, which is a channel state information reference signal, and its purpose is to enable the UE to measure channel quality, especially during the beam forming and massive MIMO. It supports beam management and link adaptation. Now, these signals and channels are really very crucial in providing the resources appropriately to the different users for different purposes and for different services. So all of these channels and signals are crucial to be mapped appropriately to give an initial access and then to have an intelligent scheduling, beamforming, and mobility management. So in summary, if you see these channels and signals, they have separate functions, and SSS is used for synchronization. Their allocation is fixed in the grid, in the time and frequency grid. We have then the broadcast channel, which is broadcasting the master information block. Its position is also fixed in the grid because UE then easily decode these particular channels and signals to then latch onto the network. PDCCH again will simulate it in the protocol session. We will see that how the PDCCH would be allocated within the time and frequency domain. We then have a user data which can be dynamically scheduled depending upon the number of users and the type of services they are using. We then have some signals, reference signals, which are assisting the PDCCH decoding and is used for channel quality estimation, especially during the beamforming and the massive MIMO.